Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 2641. Cousins in binary 2. Given the root of a binary tree, replace the value of each node in the tree with the sum of all its cousins' value. Okay. Two nodes of a binary tree are cousins if they have the same depth with its different parents. So this is the important note, and return the root of modified tree. Okay. Note that depth of the node is the number of edges in the path from the root node to it. Okay, fine. Okay. So let us take this as example. Now, what is maybe cousin? So cousin is something like it has a same depth. Two nodes have a same depth, while their parents are different. Okay, fine. So from this tree, I can say this 4 and 9 are cousin. No. But this 1 and 7 are cousin because they are at same level. They are at same depth. And also 1 is 4's child, while 7 is 9's child. Can I understand this? Such that they two are what? Cousins. And also 10 and 7 are cousins. Other than that, there is no cousins. Yes? Okay. So what is the sum of all cousins of pi? There is no cousins exist. So I will make this as what? 0. And what is sum of all cousins of 4? There's no cousin 0. There's no cousin 0. No. What is sum of all cousins of this node 1? So I can say node 7 is the only cousin. So I put 7 here and that's 7 here. Okay. Now for the 7, what should we put? I should put 1 plus 10 here. So it will be 11. So this should be my output. Hope you understand this, right? So this is what a problem statement states. Now, how to do this? Okay. Here, we want the all cousin sums, right? All cousin sums as our answer. Okay, let me take this as an example. Now, what this cousin signifies? It signifies that we want a depth, right? We want depth of same depth. So I can say it is a same level. So whenever there's a word called level, we can try out what? A BFS and level order traversal. Okay, how to try the level order traversal here? Fine. Now, let us take this is individual level, this is individual level, and this is individual level. And take the sum. It is 5. It is what? 13. It is what? 11 plus 7, it is 18. Okay. If we found these individual values, then when we write the neighbor of this, the cousin sum for this 1, I can say 1 plus 10, 11, minus this 18. So 18 minus 11 should be my answer for this node 1 and also for node 10. Can you understand this? See here, I will take the sum of these two siblings. And other than this 2, I can say whatever there is a node in this tree, in this level, I can say that should be what? That should be my cousins, right? That should be my cousins. Other than that, these 2 siblings, I can say other than that, what? Cousins. So I will take this sum, and I will subtract from that sum of all values in that level such that I will replace that in what? This both cousins. This both siblings. Can you understand this? Okay. So what is my siblings? Those are nodes which are belong to the same parent and in the same depth. So it is what? A sibling. Okay. Hold on. Now the first step is want to take the sum of all levels, right? This 5, this 13, this 18. How to take this sum? So just do a level order first. So take a few. Okay. Initially I will put 5 here. Okay, no. Other than that, there is anything in this level? No. Okay. Take outside this 5. Okay. What's the value of this node? It is 5. So take this as our sum. Take this as our sum and mark it as what? Just take an array like this. And put what? 5 here. So 5 is the 0th level's sum. Can you understand this? Hold on. Now, I want to put what? I want to put 13 here. I want to put a 4 here and also 9 here. So these 2 are the child of this 5, right? Okay, this is the end of what? End of this level. Okay, now I want to pop this 4 out. While popping this 4 out, what should it do? I should put in my next level sum. Okay, plus. Now, after popping this 4, what are the child of this 4? I can say 1 is one child and 10 is one child. So these are the 2 childs for this, right? Okay, fine. Now again, I want to pop this 9 out, right? Still the level is not over. Okay, while popping this 9 out, I want to add in my first in this because the first level value. So it is equal to what? 13. 13. Okay. Now up to this, the level is over, but we haven't added the value. So let me add this child. Okay, up to this, the level is over. Now, plain. So take this one off and put one here. Yes. So whether one has any change, no. Now pop this 10 out, put 10 here. Whether 10 has any change, no. Pop this 7 out, put 7 here. Whether 7 has any change, no. So what is the value? It is 18. So I can say my array is something looks like 5, 13, so 18. So this is 0th step, first step, and second step, all nodes are. Can you understand this? Fine. Now, let us take the same example again. Now, just tell me, now what's our goal? Our goal is to take the sibling sum, and turn it to a what? Turn it to a cousin sum minus those sibling sum and put in the sibling sum, sibling values. Okay. I will tell you how to do it. First of all, place here. Now, we are going in the DFS traversal. We are going by what? A DFS traversal. We can use a periodic traversal here. Okay, periodic traversal. Now, initially I am at what? This root level. So, initially I make this root as what? 0. Always. My root doesn't have any siblings, any cousins, any nothing, right? So, I will make this as what? Surely got 0. Okay, I'm making this 0. Now, I want to check whether I have a left child and also a right child. I have a left child, right? Okay, so 4. And whether I have a right child, yes, I have plus 9. We see what? 13. So 13 is the sum of siblings, right? Sum of siblings. Okay, now what is the first in this value? It is 13. So 13 minus 13 is equal to what? Is equal to 0. 0. So I want to replace this value as what? 0. And this value as what? 0. Can you understand this? Yes. So at first, the depth is what? Depth is 0. So I will take depth plus 1 in this. Okay, now traverse to here. Now it will be what? Plus 1. So depth is what now? 1. Depth is what now? 1. Okay, fine. Now, whether I have left child, yes. So take the sum. Whether I have a right child, yes. Take the sum. Okay. What is sum? It is 11. Okay. Now, what is the total sum of the nodes in the second level? It is 18, right? So 18 minus 11 is equal to 7. Okay, replace this both. Simple. Okay, now again come here. Okay, whether it has any change? No. So don't do anything. Go here, it is also null, return. Go here, it is also null, return. And return. Go here. It also doesn't have any change. Go, return, and return, backtrack, and it comes finally to a here. Okay, fine. Now, again, I want to check whether this node has any left side. No, it doesn't have any left side. So 0 plus whether it has any right child. Yes, it has 7 as a right child. So put 7 here. Okay, now which is equal to 7. Okay. What is the depth of the second level? So depth of second level is 18, right? So 18 minus 7 is equal to what? It's equal to 11. So replace my both sibling to 11. But there is very only one sibling. So change it to 11. Okay, go down. It is null. It is also null. So it also written. And it backtracks. And at last it will be written. So now what is my node value? So sorry, what is my tree? I can say my tree is 0. Here also 0. Here also 0. Here it is 7. Here it is 7. And here is what? 11. So this is my output, right? This is my output. I found an output successfully, right? So one here and here. We are just taking the level sum. Then we are going into an individual node and taking the sibling sum such that level sum minus that sibling sum should be the cousin sum, right? Should be the cousin sum. See here, cousin sum is equal to level sum minus sibling sum. So this would be my cousin sum formula, right? Simple. Okay, now what is the time and space constant? Okay, what's the time constant? I can say time constant will be O of n because we are traversing each and every node only one time. Okay, now what's space constant? I can say space constant will be O of x, the height of this binary tree, because we are using a recursion, right? Okay, so this should be my time and space constant. Okay, let us see the code here. Yes. Now, initially I am taking a auxiliary array to store each and every level sum. Okay, now level is equal to initially 0. Now q is equal to root. I am just taking the root in my q. Now, while q is not equal to empty, then what should I do? I taking the running sum s is equal to 0. Now, for I in range of the each levels, I'm taking the each levels in that, and node is equal to, I'm taking the front value of q and popping it. Now, s plus is equal to node value. I'm taking the running sum. I'm incrementing my running sum by what? The node's value. Then, if there exists left node, left child, just place it. If there exists right child, just place it inside what? Inside the queue. Then, at last, after finishing this one level completely, just place that level sum into what? Into the this array. Into that array. Fine. Now, def DFS root comma depth. So we want to do what? Root comma. We want two parameters, root comma depth. Now, if there exists no root, then just return and s is equal to 0. Initially, I'm taking the sum as 0. Now, if there exists left child, then take that left child value. If there exists right child, just add that right child value. Okay, so I got what? Sibling sum. Now, what is the formula to get the cousin sum? If there exists left child, then do what? Left child value as total level sum minus the sibling sum. Total level sum minus the sibling sum is equal to what? Cousin sum. Same thing for the right also. Now, just go for what? A left subtree and also for right subtree, incrementing my depth to what? Plus 1. In each and every time, my depth will be plus 1. Right? And DFS of root comma 0. So, I am taking what? A root comma 0, which means depth is initially 0 and taking the root as by this root parameter. Now, at last, I am just taking what? Root dot value is equal to 0. Why I am doing this? Because always, my main root, the tree's root is always what? 0, because it doesn't have any cousins, it doesn't have any parent, it doesn't have any siblings. So, if there exists no siblings, what is the sum? It should be 0 only. That's why I'm changing it to 0. Now, just return root. Let me submit it. Yes, it is submitted successfully. Thank you.
and the other hammer.com.